This section, we wanted to talk about exponential equations. So we went over linear equation before. Linear equations, when your exponent is 1, right, with the variable. Here, exponentials, your power, your exponent is unknown. That's what we call exponential equations. And we could say this is going to be basic form of exponentials, right? The basic graph should look like this. If your b is positive, right? And if your b is fraction form, then this is the shape. We will talk about in this section growing and decay. So when you have a growing, that will be additions. Decay will be the subtractions. So example 1 is to making sure that you kind of understand what exponential equations representing, right? So the first one is the equations. So if this equation is given, we should know this is exponential because unknown variable x is in the power places, right? So we call that exponential. If exponential is given, initial value is going to be this value right here, 430. So let me write that down. And growth or decay, which one is it? So if you have, remember it's 1 plus the rate is going to be growth, and 1 minus rate will be the decay. So if your multiplications, so this is the area of B, right? If your B location is 1 point something, that's going to be growth. If it was lower than 1, smaller than 1, that will be decay. So this one is 1.15, so we will say this is growth. And your rate is going to be this part because it's 1 plus. When you subtract 1 from it, that's going to be rate. So it will be 0.15 converted to percent. It will be 15%, right? Let's try one more. So if you have y equals to 23 times 0.8 times a to the x exponent. So this is exponential, right? Your initial value should be 23. And you see 0.8, which is smaller than 1. So this is going to be decay. And then the rate is going to be 1. How do you get that 0.8, right, from 1? So it will be 1 minus 0.8 is going to be 0.2. And when we change that to the percent, it will be 20%. So if you decay 20%, that will give you 0.8 because you're subtracting 0.2 from 1, right? So the next example is trying to go the other directions. Now you have initial value, you know if it's a growth or decay, and your rate. So how are we going to create our equations with that information? So we understand the initial value will be something that we will start from, right? It's growth. So it will be 1 plus, right? 1 plus what number? So this is going to be 1 plus what number? 0.05, 5%. So you're doing 1 plus 0.05, right? Growth is 1 plus, and then 5% is 0.05. That's going to give you 1.05. This is exponential, so let's put the x on the power. So next one, you try before you watch this video. Okay, so if you tried it, your initial value 52, And decay means 1 minus. So this is going to be 1 minus because it's decay. 10% means it will be 1, 2. So it will be minus 0.1. And what do you get? It will be 0.9. So you're going to get 0.9 exponentials x on the power. So this is how you're going to build exponential equations with the given informations. Okay, so if we're looking at example 2, what they're asking you to do is just explain you already have equations about this Verizon store, right? So this is already information given. What's T stand for? That T, which is this value, is represent the total number of Android smartphone users or contract, right? So if we wanted to explain what this is, let's see. So I may rewrite it. That 86, we can tell that's going to be the amount. It started in the beginning. So January 1st, 2010 is the first measurement, right? Right? That's how we started. So this is number of the contract that they had in this date, the starting date, right? And then what else we have? 1.64 square, that's equals to 231.3056 is given. So this one right here, we can tell that's equals to 1 plus 0.64, right? So we can tell this is going to be rate, and this is the growth, right? Decay. Instead of decay, it will be growth. So growth rate is going to be 64%. And this 2 right here, square, show in a second quarter, right? This is going to be the terms. So second quarter, approximately the Android user contract is this number, right? That's what you're seeing in this formula. So with that in mind, if we're looking at example 3, this time, this is the year started, and that was measure population in India, right? In 2008, and the rate is 1.34% per year. They want you to create equations, exponential equations, so that they are mentioning this is exponentials, right? And also, once you create the exponential equation, they want you to product population in 2020, right? So let's get the equation first. So you will say population is equals to starting amount at 2008 was 1.14 billion, right? And then this is exponentially growth, so it will be 1 plus, right? What was the rate? 1.34. So change to decimal will be 0.0134 to how many years, right? T. We can simplify this one a little further by adding. Will be 1.0134 to the T. So once we get the formula, then what we can do is, so this is the formula they ask, and then the next thing we wanted to do is trying to figure out the population in 2020, right? So how many years after is that? So you're going to do 2020 minus 2008, the starting year, this amount starting year, right? So when we subtract that, we get 12. So this time you're going to replace it into the formula where t equals to 12 to find out your populations, right? So when you plug in that into calculator, this is decimals, and it's going to give you really, you need to round off, and when you round it, it will give you 1.337. And don't forget, we're talking about billion, right? So that's how we're going to use exponential equations. Let's try another one. Again, example 4, read the problem and see if you be able to set the equations. And then watch this video. Look like the most important information I have here is begin 100 milligrams, right? What's the rate, right? Rate is going to be 13% each day, right? So just setting your, and don't forget this is going to be decay. So the first thing you need to do is setting the formula for it. So begin with 100. That's the beginning value. Decay means subtracting percent, and then exponents. It will be day, right? Day. So that will give you 100 times 1 minus 0.13, so that gives you 0.87. So that's the formulas. And they want to know the future value after 1 week. But the measurement we have in time is a day. So you need to change that 1 week into the day. So that's going to be 7 days. So when you replace that into 7, and place into the calculator, you should get something close to 37.73 milligrams for that problem. What about next one, example 5, right? It's a, again, you can pause this video, try them and see if you can get it, and then watch video after. This one is initial investment is $10,000. So that's going to be starting amount, right? They want you to write the formulas with different case. So let's look at the first one. That's increasing 5% every year. So how are we going to write that, right? That's going to be always start from 10,000 because that's the initial amount. And then 5% increasing, so it will be 1 plus 0.05, so that gives you 1.05, and times. That's how you can write your formula for the first case. The second case, your formula, again, start the same initial amounts, and then same, this is going to be same percent increasing, so it will be 1.05. Only thing different on this one is going to be 3 years, not every per year. So the way that you're going to write your exponential is going to be trying to make it into the per year as 3 years given. So you're going to do t over 3. Right? This one is going to be exactly same as the other one. Again, only thing different. So if you look at it, the difference is going to be every year, every 3 years, every 6 months, right? So in this one, how do we write 6 months? Well, so when you multiply, it should get 1, right? So 6 months, you're going to multiply by 2. That way that you will get per year, right? Which is going to give you 12 months. 1.05, so you're going to get 2t on that one. So that was the example of how you can adjust your times or period if you have different way of expressing it. So here is another problems where you can do exercise of building the formulas, right? Once you know how to build it, then you should be able to find out whatever you're asked. So let's see if we can do the first one. This is talking about populations. So it will be equals to P. And it start with measurement in 2005. The population was 83.6 thousand. So that will be the initial values. And then it was growing at the rate of 11.5, so will be 1 plus 0.115. So it will be 1.115. And it said every 8 years. Every 8 years. So that will give you t over 8. And that's how you're going to build the equation for the example 1. What about example 2? So this is company sale. Initial sale in this year and has been decreasing, and this is the rate. So decreasing at this rate means you're going to do 1 minus 0.032, right? So sale is equals to initial value of 14.2 million times decreasing will be 0.968, right? That gives you 0.968 to the per quarter. So that's going to be 4t. This many exercise on building exponential formula should be helping you to do your homework. And we're going to use that in other sections that we're going to look at it too.